Hello friends, this video on aldehyde ketones carboxylic acid part 15 is brought to you by examfear.com. No more fear from exam. So for the chemical properties of aldehydes and ketones, we'll talk about the nucleophilic addition reaction. In that, we'll talk about the addition of hydrogen cyanide, addition of sodium hydrogen sulphide. We'll talk about the addition of Grignard reagent. We'll talk about the addition of alcohols, addition of ammonia and its derivative. We'll talk about reduction. In reduction, we'll talk about reduction to alcohols, reduction to hydrocarbons. We'll talk about oxidation. In oxidation, we'll talk about Torrance test, Felling's test. We'll talk about oxidation of methyl ketones by haloform reactions. We'll also see reactions due to alpha hydrogen. We'll see alpha hydrogen is more acidic. We'll talk about aldol condensation in this alpha hydrogen reaction. We'll talk about cross aldol condensation. We'll talk about Cannizzaro reaction where there is no alpha hydrogen, and we'll also talk about electrophilic substitution reaction. So we'll talk about these kind of mini reactions for aldehydes and ketones. Let's start with the first reaction, that is nucleophilic addition. So this we've already discussed any aldehydes and ketone due to carbonyl group. So what will happen is this will have slightly negative charge and this carbon will have slightly positive charge. So if my nucleophile is strong, the nucleophile will attack this carbon, right, and it will form O minus, and then H plus will come from somewhere in the system because we'll have this reactions in the acidic medium, and you get this kind of product. Second case, if my nucleophile is not that strong, then first thing will happen is, if it is strong acidic medium, this H plus oxygen will attract this H plus, and then it will form carbocation because this bond will break in this fashion, and then since it's a carbocation, then nucleophile can easily attack this. So you will get the same product in both cases. This is what you will get. With the typical reaction mechanism for a nucleophilic addition reaction. So in nucleophilic addition reaction, we will now first study the reaction with HCN. So HCN is hydrogen cyanide. It easily breaks into H plus and Cn minus. Cn minus is a good nucleophile. So the typical reaction that will happen here is Cn minus. This will be slightly negative, slightly positive. Cn minus will first attack this carbon. So what we'll get is this with Cn and with a negative charge. And this negative charge will attack this H plus, and what you get is Cn and OH. This is the typical reaction mechanism we'll see, right? So let's see for aldehyde. Let's see for aldehyde now. So let's suppose I have CH3 COH. And react with HCN minus N plus. This moves in this direction, slightly negative, slightly positive. Cn minus will attack this carbon from back. So what you get is CH3, C, I get Cn somewhere, I get H somewhere, and O minus somewhere. And this O minus will again attack this H. So what you get is CH3, CnH, OH. This is called acetaldehyde cyanohydrate. Acetaldehyde cyanohydrate. This is what you'll get. This is my acetaldehyde actually. Correct? The next is, let's try with ketones. Let's take CH3, CO, CH3, simple mechanism, I'll take acetone. Same thing here, HCN, H plus, Cn minus, slightly negative, slightly positive. Cn minus will come and attack this carbon with a positive charge, right? What you get is CH3, C, Cn somewhere, CH3 again here, and with the oxygen with a negative charge because this bond will break, and this oxygen will now attack this H plus. So what you get is CH3, COH, CH3 and CN. You call it acetone cyanohydric. And please note, this HCN is dangerous to work. So please be careful when you are working with this in the lab. So this is the typical reaction of acetone and aldehyde with HCN. Pretty simple reaction. Let's talk about the reaction with hydrogen sulphide. So we have NaHCSO3. This is my sodium hydrogen sulphide. And when you see, this is an equilibrium where it breaks into Na plus, H plus, and SO3 2 minus. This is how it breaks. Correct? And this is also my strong nucleophile. Correct? So let's see this reaction mechanism. I'll do it for acetone. It's all same for aldehydes and ketones, so you just have to see what I'm doing. Now this reacts with SO3 2 minus. This again, this is a carbon is a slightly positive charge, oxygen is slightly negative charge. SO3 2 minus will attack this carbon. So what you get is CH3 SO3 minus, because it has 2 negative charge, and this bond will break into carbon plus and oxygen minus and CH3. Correct? Now what I have in my system, I have Na plus and I have H plus, right? Na plus and H plus. This oxygen has lone pair to attract this H plus, SO3 will attack this Na plus. So what you get is CH3 OH, CH3 C, here you have OH, CH3, here you have SO3 Na. And this is the reaction mechanism. Acetone bisulfite compound. And there is something special about this process. See, this process can be used to separate carbonyl compounds and non-carbonyl compounds. Any compound which has this carbonyl group with the compound which doesn't have, because the compound which has carbonyl group only will react to this with this NaSCO3. Now, if you want to get back your reactant, the only thing you have to do is you have to heat this with some acid or even alkali. Just heat this. The moment you heat this, you will get your reactant back. So this is also used for the purification of aldehydes and ketones, because if it has some impurities, you can ignore that. Correct? Because you can easily get back your reactant by just heating with H plus. So it is used to separate carbonyl compounds and non-carbonyl compounds, and it's also used to purify aldehydes and ketones. The next is reaction with the Grignard reagent. We have seen this kind of reactions many times. So I'll just give you an overview. This is my any aldehyde or ketone. Slight negative charge, slight positive charge. And if I have my RMGX, in RMGX I know R has negative charge, Mg has +2 charge, and again X has negative charge. So R minus is a strong nucleophile attack this carbon. What will happen is this becomes R here, this becomes O minus, and this MgX will, oxygen will attack this MgX, because MgX as a whole has a plus charge, right? +2 and -1 has plus charge, so it becomes O MgX. Correct? This is what you get. Now if you see, what happens is, now if you do a hydrolysis, you put some water here, right? So now this water, if you see, this also has slightly negative charge, slightly positive, slightly negative. This slightly positive will be attracted by this oxygen here. This oxygen will attract this hydrogen. Because it has lone pair of electrons, it has slightly positive charge. Actually, I made a mistake. This is slightly positive. This is slightly negative. Yeah. Correct. This is slightly negative. So with this, what will happen is this bond will break. O and MgX bond will break now. Correct. So with this, what you get is there is R here and COH. It will become an MgX, and this extra OH minus will come here because this bond will break. This bond will break, and you'll get this. Correct. So if you use aldehyde here, you get 2-degree alcohol. You get 2-degree alcohol. And if you use ketone, you get 3-degree alcohol. I can show you how. See this one, right? Is my this. So if I start with, if I add H here and R here, let me show you. Or let me take one example. This is my aldehyde. So with this, if I add MgX or MgX, let's suppose with this I add C2H5 right? What will happen is the C2H5 will attack this carbon, and this MgBr will go and you get OH here, right? So what will I get is CH3, C2H5, it is H, and this becomes OH. This is what I'll get. And this, if you see, is my 2-degree alcohol. Correct? Instead of this, if I use, let's suppose, ketone, and in this again C2H5 MgBr. C2H5 is negative charge. Attack this carbon, go off. What you get is C1CH3 here, 1CH3 here. Here my C2H5 will come, and here O minus, and then H plus H will come. This is what I'll get. And if you see, this is the 3-degree alcohol. Correct. So if I use aldehydes, I get 1 degree or 2 degree. If I use actually, for example, if I use HCOH, and in this case I use C3H3MgBr, let's suppose. So what I get is 1 degree alcohol. Yeah. So I get 1 degree or 2 degree alcohol. If it is formaldehyde, I get 1 degree. If it is normally any other aldehyde, I get 2 degree alcohol. For ketones, I always get 3 degree alcohol. This is the reaction mechanism, pretty easy reaction mechanism. We have seen this kind of reaction so many times. So the good thing about Grignard reagent is R minus is a very good nucleophile. Now we'll see the reactions of aldehydes and ketones with alcohols. So generally we have aldehydes or ketones. So when they react with alcohol in presence of HCl, H plus, it forms acetals. Actually, it forms hemiacetals, and then it reacts with more alcohol to form acetals. Acetal are the form R, C, let's suppose H here, OR dash, of this form. This is called acetals. It can be R also here. So if you have OR dash form, it's called acetals. See the reaction mechanism. Generally it is for aldehyde, but ketone also takes part in this reaction because aldehyde is more reactive than ketone, but both of these take part in this reaction. So I have R, COOH, let's suppose I have this, and I have my alcohol, let's suppose R1OH. Correct. Oh, will have this lone pair of electrons. Now what will happen is this is slightly negative, this is slightly positive, right? So this plus slightly positive, so this lone pair of electron will be attracted towards this carbon. So what you get is RCO minus, and then you get OR1 H, correct? This is H already here. This is what you get. Now since oxygen is giving electron, it gets a positive charge. Somebody has to leave, so H plus H says okay, I leave and join this O minus. So what happens is this bond breaks in this fashions, and this O minus will attract this H. So this becomes R, H, OH and OR. This is called hemiacetal. Correct. Now this reaction happens in equilibrium actually. It's all in equilibrium reaction. So now you add more and more alcohols. So with this what happens, I'll show you, you'll form acetal. It's R1 actually. So let's see the mechanism here. So what happens is first H plus comes. You have this acidic medium as I told, right? So H plus will have lone pair of electrons, will attract this H plus. This will become H2O, and the water will come out with a positive charge on this carbon, right? Now on this, ROH will attack. So this will form this compound. Now since this oxygen has given electron, it will get positive charge. Since there's a positive charge, this oxygen, it has to get rid of the positive charge. So hydrogen will say, okay, I'll break this bond, and hydrogen will go off. And this is my acetal. Correct? So this is the mechanism for reaction of aldehydes and ketones with alcohol. Preferably, aldehydes react more. Now let's see the reaction where ketones react with dihydric alcohol. So instead of alcohol, it is dihydric alcohol. So it gives cyclic acetal. I'll show you the reaction. For example, I have a ketone and it reacts with CH2, CH2OH. This dihydric alcohol, in this case I took ethylene glycol. Correct? So what happens here also, this goes in this fashion, right? And slightly positive charge, slightly negative charge. Oxygen has the lone pair of electron attracted towards slightly positive charge. Correct? So this, with this, what you get is R, C, R. This bond breaks positive and negative. There's oxygen here, H here, CH2, CH2, OH. And this is O minus. Correct? Now, since the bond broke and oxygen gives electron to this carbon, oxygen gets partial positive charge. So since this oxygen is electronegative compound, it doesn't want positive charge, hydrogen will say, okay, I'll go away from here, and this H plus will go and this positive charge will also go. So with this, it will be neutral. And now what will happen is, if you see, this H plus will attack this lone pair of electron. So with this, the product you get is R. There's a C here, C here. The O minus, here you get O, CH2, CH2, and H, and this H. And since oxygen gave electron to this H, oxygen gets a positive charge. Since this is H2O and so it's a heavy group, it will come out. So with this, what you get is this compound CH2 and carbon gets a positive charge. Right? Carbon is a positive, oxygen is a negative, they will form a bond. And the charge will go off. And this is what you will get. This is a cyclic acetal. Correct? So this is the reaction of aldehydes and ketones with alcohols and aldehydes and ketones with dihydric alcohols. So for dihydric alcohol, we generally take ketones. So the typical reaction mechanism for this, you have aldehyde ketone. It reacts with NH2Z. Z can be anything. Z can be hydrogen, alkyl group, aryl group, anything. Right? And NH2Z, if you see, it is nothing but H plus and NHZ minus. That is how it's broken. Right? So this reacts, and what happens is this NHZ minus will attack this carbon, so it becomes NHZ, and here O minus reacts with H plus, you get H plus. This is the typical reaction mechanism, and this actually is a little unstable, and you get C and Z. Water comes out. This is the typical reaction mechanism. Right? So we'll see one example. For example, I have aldehyde here and it reacts with NH2. Instead of Z, let's have OH here. This is called hydroxylamine. This happens in the presence of acid, obviously. So what happens is, in this fashion it goes, and here NHOH minus, if you see, this is nothing but NHOH minus NH plus. Correct? So NHOH minus will attack this, and H plus will attack this. So with this, it will form is this guy, NHOH, and from here it will you'll remove water and you'll form CH3C double bond. Here you'll get double bond, and OH was there, this H and this OH will go off. This is the reaction mechanism. Let's see a better and clearer reaction mechanism. So here, let's suppose I have CH3, CO, CH3. Right? So the first thing that happens is the acidic medium H plus, it will react, and this O minus will react with H plus. So what it will form is CH3, CH3, C with a negative charge, sorry, C with a positive charge, and OH. Correct? Because this bond will break, negative and positive. So carbon will get a positive charge. Now on this I have, let's suppose I am using NH2CH3. Nitrogen has a lone pair. So this lone pair will get attracted towards this carbon. Right? So what will form is CH3, CH3, C, NH2, NH2 and CH3. Now since carbon, this nitrogen gave electron to this carbon, nitrogen will get a positive charge. Right? But nitrogen doesn't love positive charge. Somebody has to go out. Right? So what will happen is this hydrogen will go out. Hydrogen will say, okay, I leave, I don't mind leaving. It's a good leaving group. Hydrogen will go out and this will become neutral. COH, and you have NH, CH3 and lone pair of electrons. correct? So now again we'll have a H plus attack. So now the question is, where will the H plus will attack? See, it can attack in nitrogen, it can attack in O oxygen also, but just now it left from nitrogen, it won't like. So let us attack this oxygen. So with this, H2O will come out, right? So it will become H2O with the oxygen will have positive charge, and then oxygen will not like positive charge, so the whole H2O molecule will come out and carbon will get a positive charge, right? This is how it will become. Now carbon want to get rid of positive charge. What are the possibilities? So one possibility is, if this hydrogen goes off, nitrogen gets negative charge, negative and positive charge forms a bond, right? Because hydrogen is a good living group here. There is no other good living group here. So what will happen is this hydrogen will go off, nitrogen will get a negative charge, nitrogen enjoys negative charge, and negative and positive charge will form a bond. So what you get is, this is what you will get, plus H plus obviously. So this is the reaction mechanism. I hope with this you understand the proper steps. What happened? H plus attacks, then NH2CH3 attacks this carbon, and nitrogen gets a positive charge, nitrogen doesn't like positive charge, hydrogen goes off, it's neutral. Again this H plus which came out wanted to attack somewhere, it attacks oxygen, the whole water molecule goes off, carbon gets a positive charge, carbon want to get rid of positive charge. Good possibilities is hydrogen leaves, nitrogen gets negative charge, and they form a bond. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.